Can you see the slide still?
Yeah, it came now, ma'am.
Okay, fine. So this is based on the coefficient of linear expansion. Write the question. Calculate the increase in length of brass rod which measures 220 centimeter at 10 degrees centigrade such that it is heated to 950 degrees centigrade. The coefficient of linear expansion for brass, that is alpha, is 0.00018 degrees per degree. Calculate the overall length at 950 degrees centigrade. Should I initialize, or will you be able to write what are the physical quantities given and what is needed, what is required to calculate? Okay, read the question. I'll give you 2 minutes. Then I'll call someone. You need to tell me what are the physical quantities that are being given in the question. Read the question.
Ma'am, like in this chapter, do we ever need to convert Celsius to Kelvin?
Not necessary, boys, because your alpha is being given in terms of degree centigrade, right?
All right, ma'am.
That we need to check with all the physical quantities. So here you can keep it as degree centigrade itself. Okay, fine. Dheeraj. Dheeraj, I need to every moment. Derek, all your assessment will be assessed even based on how you respond in classes, boys. Derek. Derek. Okay, yes. Microphone is not working. It's fine. Okay, Kritya.
Yes,
Kritya,
ma'am.
let me know what are the physical quantities which are being given.
Okay, ma'am. So they have given length and temperature at in the starting.
Okay, what is
Initial length and
what is
initial length.
Okay,
Ma'am, that is initial length is 220 centimeter. Ma'am, we don't need to convert to meter, right?
No need, because everything is in centimeters in CGS system. Okay, T1 temperature, initial temperature.
Ma'am, it's
10
10 degrees
degrees.
Celsius. And then they
Okay,
have
what is the
given
final
the
temperature?
final temperature, they have given it as 950 degree Celsius. And they have also
Okay.
given the this thing. There is
Value of alpha.
alpha, that is 0
Coefficient.
0.0018. And that is
Oh,
so
1 okay.
ma'am,
Exponential, yeah, you can go for exponential powers
yes, ma'am,
also.
that's it.
Fine. What is the question? What is the question? You have to calculate.
So we have to
What is
find the increase in length. So if we find the final length, Then we have to subtract it from the initial length.
Okay, so what you need to find is, this is the question that is being checked. These are the things which are being given. So what is the first step to find is delta L, which is equal to L2 minus L1. So you need to find what is delta L, engine length, and then you can find the final length. Thank you, Krithya. Prasanna, what is the formula for coefficient of linear expansion? Check your previous page.
Ma'am, I'm getting, okay, the formula is delta L by L1 delta T into delta T.
Okay, fine. Now others, please solve the numerical. I'll give you few minutes. Kavin, Harish is there in class. Harish, his microphone is not working, boys.
Yeah, no.
Okay, fine. Abhishek and Austin, I want the answers from you. Even others, keep trying. So first find delta L. First step is delta
And then no need to find
L.
L2, right? Because they are just asking the increase in length. That is delta L, right? We just need to find
calculate
delta L.
the
That's
overall
it.
length. Calculate the overall
Okay,
length
overall length also, yeah. Okay.
at the temperature, right? So that in that case, this alpha into L1 into delta T. I want this answer from Austin, sorry, yeah, Abhishek and Austin. Sorry. This is the first step. So. Austin or sorry, Abhishek or Austin, did you calculate the value of delta L? Sorry. At least you can say yes or no. Austin and Abhishek, we are still doing, say, we are still calculating.
I'm still doing.
Okay, fine. What about the other person? I can't see Austin and who is that? Austin and Abhishek is here. Austin, switch on. Abhishek is here. Austin, fine. Austin, switch on your camera, Austin. Calculate. At least delta L, can you find? Who has completed the first part, can you tell me the answer for delta L?
I completed,
yes.
but I did it in meters.
Oh, no problem.
Okay.
Ma'am, I got
3.76 into 10 raised to minus 2.
Okay,
yes,
fine, fine. Shall we check the answer? Or should I give you some more time to calculate others?
Ma'am, is it 3.7224?
1 second, I'll go for
yes,
the next
ma'am.
slide.
Even I got the same.
Is that correct, boss? Is that delta L? Are you getting in
yes,
centimeter?
Yes, ma'am, yes.
Okay, then the final
Yes,
length. Okay, this is a delta L. So your length L2 will be equal to, because delta L is equal to L2 minus L1. or L2 will be L1 plus delta L. So delta L is 3.72, L1 is 10 centimeter. So 220 is 220 centimeter. So that comes out to be 0.72 centimeter. Did you all calculate this, boys? Have you calculated?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Are you getting these values, boys?
Yes, ma'am.
Yes.
Now I'll go for derivation, then we'll come back for the numerical ones. This is the question, was relation between, it's a relation
Ma'am?
between, yes,
These type of questions will be coming for the test, right?
yeah,
Annual exam.
correct. Annual
Okay,
exams.
ma'am.
So the coming up chapters will tell you what are the topics which are going to come, whatever topics we are doing right now, and one small topic which I think so I'll be able to take tomorrow. Only these things will be from this chapter. Okay, right, this was relation between,
Ma'am,
yes,
when is the coming up test exam?
which examination? There are three. One
The
is
self-evaluation one.
a self-evaluation. Weekend, this weekend you prepare, boys. It will be next week somewhere, right? You need to
Okay.
prepare. No, the thing is that it's like a case-based question. The paragraph will be given. You have to just read the paragraph, comprehend, and do. And that's the reason
Okay, ma'am.
all the topics which are being given, refer your textbook. Right, boys. Relation between coefficient of volume expansion and linear expansion. Important 2-mark question, boys. Relation between coefficient of volume expansion and coefficient of linear expansion, which means they're asking you to get the relation between gamma and alpha. So I think I'll go for the new slide.
Ma'am, volume expansion, is that the same as cubical expansion?
Yes, same. Boys, I'll go for the new slide. So this relation is important. So now just let us consider, you need not write the statement, you can just write the initial thing. You have a cube, say the volume of the cube, initial volume of the cube is V1, length is L1, temperature is T1. So you can just specify L1, V1, T1. This is the original volume, original length. Say after heating, the length of the side length also is going to change. So the final volume is V2, temperature E2, side length is L2. This is the initialization, right, boys? When you're deriving, you just write L1 hyphen L2 hyphen V1. I'm just drawing right now. We'll start doing the derivation. Are you clear, boys? So the original first step, the original volume of the cube, original volume of the cube. What is that? V1. In terms of length, how should I write, boys? It's a cube. The original volume of the cube is V1. In terms of side length, what should I write? What is the volume of the cube? Fadil? Right, boys. The new volume of the cube.
Ma'am?
Yes.
Can you show the previous slide for me?
Which one? This one? The numerical part.
No, ma'am, not the numerical. The subheading.
Just
Yes,
put
ma'am.
it in the chat. Put this in the chat box, boys.
Okay,
So,
ma'am.
now we'll go for coefficient of linear expansion. What is the formula for coefficient of linear expansion? I keep calling you people. What is the coefficient of linear expansion? Shamshul? What is the value? Sorry, what is an expression for alpha?
Delta L by L delta T.
Okay, delta T.
Yes, ma'am.
What is delta L? What is delta L? Change in length. So what should I write? L2 minus L1 divided by L1 into delta T. Right, boys? So now I want to get an equation for L2. Can you get an equation for L2 here? Was from this equation, let it be 1, let it be 2. From the previous equation, can you get me an expression for L2? If I cross multiply, what will I get? L2 minus L1 will be equal to alpha L1 into delta T. So what is then L2? L2 will be L1 plus alpha L1 into delta T. So then what is L2 now? I'll take L1 common, 1 plus alpha delta T. Is that fine, boys? Is that fine? Just check, are you getting this?
Yes, ma'am.
What is the heading of this derivation?
The relation between coefficient of volume expansion and linear expansion. That is, you have to prove the relation between gamma and alpha. Boys?
All right, ma'am.
From this expression of alpha, I am getting an expression for L2. Is that clear? Is that clear, boys? Can I move for the next one?
Yes, ma'am.
Okay. Next one. Okay, you got the value for L2. Now, taking cubes on both the side, what is L2 cube? What will be L2 cube, boys? You have L1 into 1 plus alpha delta T. I'm taking cube on both the sides. Okay, now I have to use this expression A plus B the whole cube. What will be that? A cube plus B cube plus 3A squared B plus 3AB squared was this identity. In this expression, your A is, the value of A is 1, B is alpha into delta T. So can you expand and write? Will you be able to expand, boss? Yeah, I'll do. 1 plus 3 alpha into delta T plus 3 alpha squared delta T the whole square plus alpha cube
Isn't it supposed to
delta
be alpha delta T whole cube for this?
Yeah, yes, boys.
Yes,
Are
ma'am.
you
I
getting
got it.
this?
Yeah.
Okay, fine. Now, in the previous numerical, have you seen the value of alpha somewhere like this? So the value of alpha itself is, right, is so low. Then if I If I square the value, if I cube the value, then what is going to happen? The value becomes still lesser and lesser. Alpha itself is 0.0018, approximately equal to 0. Then alpha squared still will have a lower value. Alpha cube still having a lower value. So you can neglect the value of alpha. Since alpha has a small, very small value, then what else you can neglect? Alpha squared and alpha cube can be neglected.
Ma'am.
Yes, boss.
Ma'am, like in the 3a square b and 3ab square terms, for one of
yes,
them
ma'am.
we didn't square any.
There is a mistake in it.
Yeah.
3
Which one
alpha
is-
square delta t, the second term.
Second terms, yeah.
It's supposed to be 3 alpha square delta t, and the third term should be 3 alpha delta t.
No, okay. Just it's an addition term, right? I'm just changing it and writing. What's the problem, boss?
Oh, okay, ma'am.
Because you check what is the value of A, what is the value of B. So in that case, higher power of alpha I'm neglecting. So this becomes 3 alpha into delta t. Is that correct? Is this fine, boys?
Yes, ma'am. Yes, ma'am.
Okay, fine. Now, what is gamma? What is the value for gamma? What is gamma? Gamma is delta V divided by V1 into delta T. So what is delta V? V2 minus V1 divided by V1 into delta T. So what is V2? V2 is L2 cube. What is V1? L1 cube. So what is V1? L1 cube delta T. I think only few minutes left. Shall I give this as a homework? Tomorrow I'll come and check.
Ma'am, like in the expansion of the identity, shouldn't that be
Is
delta
wrong?
square?
No. What is that the problem was
Ma'am, it
over
is
here?
right.
It is right or wrong?
Okay, maybe I'm wrong. Okay, it's fine.
Was check this. When you're going for identity, anyway, I'm not taking much of your time. So boys, here, this is the expression. You have to substitute for the value of L2. Just check whether the relation between gamma and alpha, something it has to come in terms of alpha over here. Till now, just copy it down, boys. Only one step is given as your homework. Complete your homework. How many minutes left? 2 minutes.
Yes, 2 minutes. No, 1 more minute.
Boys, okay, fine. Boys, these, okay, fine.
So, ma'am, we have to.
Yes, boys.
Ma'am, we'll have to write delta t in terms of gamma, right?
No, gamma is already there in left hand side. You have to substitute for L2 cube.
Okay, ma'am. All right.
Right? So gamma is already there in the left hand side of the expression. Substitute for L2 cube, right? And then get the relation between gamma and alpha. So let's just do this work. Should I put this in the chat box, boys?
Ma'am, already done by Jonathan.
Already.
Yes,
Okay. Thank you, boys. Thank you.
Thank you.
Thank you for the students who are responding. I don't know. A big thank you for the students who are not responding.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Just complete this work, boys.